Introduction. Functions of the form y is equal to a times b to the power of x plus q are called exponential functions. Here, a, b, and q are constants. What is the relationship between the two variables, the independent variable x and the dependent variable y, in this type of function? Recall from chapter 2 that an exponent is a way of writing a number that is multiplied by itself several times. Looking at the function y is equal to ab to the power of x plus q, we see that the base is b and the exponent is x, the independent variable. Therefore, there is an exponential relationship between the independent and dependent variables because of the b to the power of x term. Here, b is multiplied by itself x times. Notice that the terms a and q are constants that are multiplied or added to get the value of the function. But the relationship between the two variables is still exponential. Let us look at the graph of an exponential function to understand it better. When the x value is 1, the y value is 2. When the x value is 2, the y value is 4. And when the x value is 4, the y value is 16. When the x value is negative 1, the y value is half. This indicates an exponential relationship. Before we study exponential functions further, let us look at some examples of exponential functions in real life. Steve and Kagiso are in the life sciences lab to study the growth of amoeba. Steve focuses the microscope on the specimen and calls Kagiso to take a look. She sees a single amoeba. After a minute, the amoeba divides into 2 daughter amoebas. 2 minutes later, each of the daughter amoebas divides into 2 daughter amoebas. 3 minutes later, the 4 amoebas give rise to 8 amoebas. 4 minutes later, the 8 amoebas give rise to 16 amoebas. This continues. If we plot the number of amoebas on the y-axis against the time elapsed on the x-axis, we get a smooth curve. At t equals 0 minutes, there is just 1 amoeba. At t equals 1 minute, there are 2 amoebas. At t equals 2 minutes, there are 4 amoebas. At t equals 3 minutes, there are 8 amoebas. At t equals 4 minutes, there are 16 amoebas. This is an example of an exponential function. Let us now consider a sum of money invested in a bank fixed deposit. A bank fixed deposit offers compound interest, as we will study in the next chapter. What is important to note is that compound interest in a bank offers interest on both the initial amount invested and the interest earned over time. The 1,000 Rand that is invested grows exponentially. We see here that a sum of 1,000 Rand invested now becomes 1,060 Rand after a year, 1,124 Rand after 2 years, and 1,191 Rand after 3 years. After 5 years, the money has grown to 1,338 Rand. The money grows faster and faster as the years go by. So it makes sense to save our money in a bank and let it grow exponentially.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.